Good morning, students. Welcome to Computer Organization class. This is Veena A. Patil from Department of CSE BLE CET Vijaypur. Now let's see next topic, that is fast multiplication. Now why do I call it as fast multiplication is because whatever Booth's algorithm is doing, fast multiplication will take almost half of its time, and the number of steps are also reduced. Okay, so let's see here first the theoretical part. As I told you, this method is directly derived from Booth's algorithm. We know that the maximum number of summands, that is versions of the multiplicand that must be added, will not exceed n by 2 for n bit operands. So number of summands will be not more than n by 2. So this principle is used in bit pair recording to reduce the number of additions. Now, bit pair recording is an example of high radix multiplication that handles more than one bit of multiplier in each cycle. A higher representation of radix lead to fewer digits, and multiplication requires fewer cycles, as I already mentioned you. Now, this implies fewer partial products, easy recording, and fast multiplication. So bit pair recording, also known as modified Booth algorithm. So it limits the total number of summands to n by 2 for n bit operands. So the number of summands will be reduced here. So let's see what is the procedure. Now for any multiplier, obtain the Booth recorded multiplier. You have already studied how to obtain the Booth recorded multiplier. So do it in the same way. Then what he says, group the Booth recorded multiplier bit in pairs starting from rightmost position. Okay. Now what we are supposed to observe here, the pair +1 -1, if you get, it is equivalent to the pair 0 and +1. That is, instead of adding 1 times the multiplicand m at shift position I to +1 into m at position I +1. The same result is obtained by adding +1 into m at position I. Now I'll tell you what does it mean. First, let us read the procedure. Now the second is, similarly, the pair +1, 0, it is equivalent to 0 + 2, and -1 + 1 pair is equivalent to 0 - 1, and so on. So thus, if the Booth recorded multiplier is examined 2 bits at a time, it can be rewritten in a form that requires at most one version of the multiplicand to be added to the partial product for each pair of multiplier bits. Now let's see what actually it means. Now, if the radix is 4, multiplication is performed with the recorded multiplier. Only the multipliers of +1 or plus or minus m and plus or minus 2m is required, all of which are easily obtained by shifting. It is same as that of Booth's algorithm, but only thing is, see, in bit pair recorded multiplier, the recording, it is reduced to half, as we have already seen. Now in Booth's algorithm, we had assumed imaginary 0 to assume one more imaginary bit that will be the sign bit. Whatever is the sign that we are assuming here, sign extension has to be done. Okay. So now if it is a 5-bit number, that is 11010, we imagine a imaginary 0 here, and we imagine a imaginary bit here which is equivalent to the sign bit. If it is 1, then imaginary 1 is there. Okay. Now how do we perform? He's saying us first you perform Booth's recorded multiplier. I mean, you know how to perform it. We just go on taking pairs. If it is 0, 0, then it is 0. If it is 1, 0, then it is -1. So on, we are going to record it. Now, after recording, again he is saying us to take pairs of these records in group of 2, 2. Okay. Now, how these group are going to be replaced by the new recorded multiplier. So if it is -1, 0, he is saying put it as -2. If it is -1 plus 1, put it as -1. If both are 0, 0, then simply put it as 0. Now this is actually the procedure which you are supposed to do, but you will get confused. So we will follow a easier method. Now in this method, just as we had written Booth's recording table, same way here bit pair recording multiplier table we are going to write. So all of you please take your notebook and pen and start writing, please. Start writing. Take your pen and paper. Okay. Now in Booth recorded multiplier, you were taking only I and I minus 1 bit, but here we are going to write I plus 1, I and I minus 1. So please plot it in a table. Then, okay. Now we are going to write the bit combination inside the table. That is, we are going to write all the 3 bits to be 0. That is, bit I plus 1 is 0, I is 0, and I minus 1 is 0. Okay. Now I will change the I minus 1 bit. I will keep I plus 1 and I same, and I will just change I minus 1. So I'll make it 1. Similarly, for the next pair of bits, that is for 0, 1, 0, I'll keep I minus 1 as 0 once, and I will keep I minus 1 as 1 for the second time. Same way, you can write for the next 2 combinations, that is for 1, 0 as well as 1, 1. Okay. Now, if you get confused like this, you simply go on writing right from 0, 0, 0 to 1, 1, 1, 0, 0, 1, 0, 1, 0, 0, 1, 1, so 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Simple binary combination numbers from 1, 0 to 7. Done. Okay. Once you have finished, please put a message that you are done. Quickly put a message. Good. Vivek is done with plotting the combinations. Yes. Who else? Nitya, Sonia, okay. Only 3 students. Please finish it fast. Simply you are supposed to write the numbers right from 0, 0, 0 to 1, 1, 1. Binary numbers 0 to 7. Done. Bhagya done. Amrita done. Quick. Okay. Okay. Now in the previous booth recorded multiplier, you have seen we had written if the bits are same, it was 0 into m, right? Same way, here also we are writing the multiplicand meaning. Okay. So please write down this. For if all the 3 bits are 0, it means it is 0 into m. If all the 3 bits are 1, then also it means it is 0 into m. Okay. If it is 001 or 010, then it is plus 1 into m. And if it is 011 and 100, we are going to write them as plus 2 into m and minus 2 into m respectively. Now similarly, the remaining two values, that is for 101 and 110, we are going to write it as minus 1 into m. I hope everybody has written this.
Yes, ma'am.
Okay. Now take down the meaning in front of that. What is the meaning? 0 into m means no string of ones found. Okay, you have to skip it. Okay. Plus 1 means end of a string of ones. Similarly, plus 1 is also meaning isolated ones in multiplier. Plus 2 means end of string of ones, whereas minus 2m means beginning of string of ones. And minus 1 means end one string, begin new string. Or you can say beginning of a string of ones. So, okay. Now we will take one example, then only we'll understand what actually it means. Now already you people have done plus 13 into minus 6 using Booth's algorithm. Yeah. So the same thing I have written here. You can see this is the recorded multiplier, right? And the number of steps 1, 2, 3, 4, 5 summonds I have to do, right? Whereas the same thing, if I do it using fast multiplication, it will be reduced almost by half. Okay, so here it is 1, 2, 3, 4, 5. It will be almost n by 2. Right? Now, what minus 1 means, what minus 2 means, that we need to understand. Now, if it is minus 2, here also we are going to take 2's complement, same as that of minus 1, which we had done in Booth's algorithm. We will take 2's complement of the multiplicand, but we will shift it by 1 bit position. Okay. So what is our 01101? What is 2's complement of this? 10010 plus 1. It is 10011. Yes, this is the 2's complement. 2's complement. of the multiplicand m. Okay, so whenever I encounter a -2, then what you have to do? You have to take 2's complement of the multiplicand, but write it after 1 bit shift. Are you copying it down? So write it as a note in your notebook. -2 times the multiplicand is obtained by getting the 2's complement of the multiplicand and then shifting it left by 1 position. So can you tell me what does +1 mean? I mean -1 mean here? You are able to see here, no? What is the meaning of -1? -2 means taking 2's complement and shifting by 1 bit position towards by 1 bit position, right? Now, -1 means it is simple, taking 2's complement of the multiplicand, but we are not going to shift it by 1 bit position. We are going to write it as it is. But if you see here in Booth's algorithm, I write each bit multiplication after 1 bit shift, right? The results or the partial products will be written after 1 bit shift position. Whereas in bit pair or fast multiplication, I have to shift 2 bits position. Okay, 2 bits position has to be shifted. You can see here 2 bits, 2 bits. For each step, 2-bit shifting has to be done. Now tell me, +1 means what? +1 means what? What is the meaning of +1? You please answer it on your microphone and answer me. What does +1 mean? What is the meaning of +1?
End of string 1 is.
End of string 1. +1 means simply put the multiplicand as it is. You don't have to take 2's complement. You already done in Booth's algorithm, no? Whatever is the multiplicand, just copy the multiplicand as it is without performing 2's complement. Okay. Same way, what does +2 mean? What is the meaning of +2? Quick. You know the meaning of -1 and -2. What is the meaning of +2? Quickly answer me, please. Plus doing the same thing, that is, it is same as that of +1. That is, you are supposed to add the multiplicand as it is, but with the shift. So this will be my +2 after 1 bit shifting. Got it? So whenever 2 appears, remember you are supposed to shift by 1 bit position. You have to add 1, 0. Okay. So we will try to solve this example. So please try to write this. That is how to record this. Let's first learn how to record this. So I will just clean this screen. So what is our multiplicand? Multiplier is 11010. Multiplicand is 01101. Right? Now I am supposed to record this using bit pair recording multiplier. Now to do so, I have to imagine a 0 here. Yes. Now unlike Booth algorithm, here we are going to take 3 bits. Now compare these 3 bits here. What is that? 100, 100. So what I should replace it with? I should replace it with -2. So I wrote it as -2 here. Okay. You people are copying it, right? Unless and until you copy in your notebook, you will not understand. Okay. Then I will take the next 3 bits. So next 3 bits stand for 101. So 101 in the table, it means -1. So just write it as -1. Right? Now I want to take the next 3 bits, but there are only 2 bits. So what I have to do? I have to extend the sign bit, imaginary 1. I have to write it there. Then all 3 are 1. So for all 3, it is to be replaced with 0. So write it as a 0. So you are going to get the new recorded multiplier as 0, -1, -2. So if it is -2, then take 2's complement of the multiplicand, shift it by 1 bit position and write here. Then after 2 bit shift, perform the next bit multiplication. That is, if it is -1, we have to take the 2's complement of the multiplicand, but without performing the shift as we did for -2, write it as it is. Now what are these which I have shown here? As we know that the product is 2n bits, so I have to extend the sign bit to make it as 2n bits result. Okay, so we extend the sign bit. Okay. Similarly, if it is 0, simply put zeros. Now perform addition of all these 3 partial products. You'll get the final result. Are you able to perform this? How many of you understood this? Put a message, yes or no. I understand whether I have to repeat or not. Put Y or N so that I will understand. Okay, not understood. Vivek. Okay. Akshata, got it. How about others? Quickly. Didn't get. Okay. Okay. Nitya also didn't get. Okay. Who else didn't understand? Okay. So I will take one more example so that we will understand it. Let's take a blank. Okay. Now we will perform multiplication of plus 30 into plus 9. Okay. Now what 13 stands for? What is the binary number?
01101.
Okay. 01101 is 13. Why do I use 5 bits? Why not 4 bits? Why do I use 5 bits? Yes?
Negative value we get in
So
5 bits,
negative
ma'am.
we can have.
Yes. Using 4 bits, I cannot represent minus 13. Okay. So if I have to represent minus 13 in 2's complement format, I need 5-bit representation. That's why we take it as 5 bits. Okay. Now, how about plus 9? What is the binary representation of plus 9?
01001.
Oh, 1001. So 01001. Okay. Now I am supposed to record this. Okay, record the multiplier. Now we will write here 01001. I want to record. So I'll be considering this as the ith bit. Then this will become I plus 1th bit. And the previous bit will be I minus 1th bit. Agree? Okay. Since previous bit is not there, so I imagine it to be a 0. So imaginary 0 we are going to write. Okay. Then we will take all 3 bits. Now 010. You have to memorize this table. Huh? You have to memorize this table. Otherwise you will not get to know how to write. Okay, what was the bit? 010. Yes. 010. Right. So 010, I should replace it by
+1.
+1. So simply write it here. Replace with.
Ma'am, we have to take the imaginary as 0, ma'am.
Yes, always. Always I minus 1th bit will be imaginary 0. Whereas here it won't be imaginary 0. Here whatever is the last bit, that you have to extend. Okay. Whereas for the LSP, imaginary 0 only you have to take. Okay.
Okay, ma'am.
Fine. Now
Yes.
I will take the next 3 bits. So this will be my I. This will be I minus 1. This will be I plus 1. 0, 0. So for 100, let's see what is there in the 100.
-2.
It is minus 2. Right? So write here as minus 2. minus 2. Now I have to consider the next 3 pairs, but there are only 2 bits. So for that, what I have to do, I have to extend the last, sorry, yeah, I have already put here 1. Yeah, 0 I have to just extend it to 0, right? Because the last bit MSB bit is 0, sign bit is 0, I am extending it. So for 0, 0, 1, what is the number that I have to write?
+1, ma'am.
For 0, 0, 1, it is plus 1.
Plus 1.
Yes. So simply write it as plus 1. Write here as plus 1. So my new recorded value is plus 1 minus 2 plus 1. Got it? Any doubts in this? You can ask me. Any doubts in this? If this bit was 1, then I would have taken the imaginary 1. If it is 0, then you have to take imaginary 0. Whereas for the LSB, it is always imaginary 0. It is just like writing instead of simply 2, 0, 2. Okay. Now what we are supposed to do, write down the multiplicand, then write the recorded multiplier. Okay. Right. Now if it is plus 1, what am I supposed to do? Simply write the multiplicand as it is. Right. So I will write it as 1, 0, 1, 1, 0. And how about the remaining bits? Extend the sign bit. So already 5 bits I have written. The remaining 5 bits I have to extend the sign bit. So it will be 0, 0, 0, 0, 0. Okay. Is it clear? I hope it is clear.
Yes, ma'am.
Okay. Now when I am going to perform multiplication with the next multiplier, for bit pair, you have to shift by 2-bit position and then write the answer. Okay. Unlike the Booth's algorithm, wherein I perform only 1-bit shifting, here I am performing 2-bit shift and then I am going to write. Now, whenever minus is there, it means you have to take 2's complement of the multiplicand. So my multiplicand is here, that is 0, 1, 1, 0, 1. What is 2's complement of this? It is 1, 0, 0, 1, 1. Is a 2's complement. Agreed? Yes or no? You agree this is the 2's complement? Yes?
Yes, ma'am.
Yes. Okay. Now this 2's complement I'm supposed to write here, but after 1-bit shift, because it is 2. Okay. If it is minus 1, then I should write it as it is. But if it is minus 2, then I will just shift it by 1-bit position. That is, I will append a 0. Then I will write it as 1, 1, 0, 0, 1, extend the sign. Sorry, it didn't write here. I will just clear it. I'll write it clearly. So after shifting, I have to write steps 1 1 0 0 1 and extend the sign bit. Done. Okay. Now to perform multiplication of the next multiplier with, again I have to write the partial product after 2 shifts. Okay, it is plus 1. If it is plus 1, simply copy the multiplicand as it is. So it is 1 0 1 1 0, extend the sign. Class it. Okay. Now add the partial products. What is the answer that you are going to get? Yes. This is the answer that you got. Did everybody get the same answer?
Yes, ma'am.
Yes. Now compare this answer with the Booth's algorithm, using Booth's algorithm, which you have done it as a homework. Both are same.
Yes, ma'am.
Nothing but it is equal to 117 plus 117. Right? I hope you can do it if it is given in the exam. Okay. Any other doubts? You have clear it now. If you have not understood it, please clear it now. I hope you people have understood this. Nitya, did you get it? Vivek,
Yes, ma'am. Got.
Yes, ma'am.
got it? Understood? Okay.
Yes, ma'am.
Okay, fine. Now try to practice some more problems, taking the questions from previous year question papers. Now in the next class, I will tell about division. So we have division. Yeah, integer division. Now here also it is also problematic one. Simply shifting and adding is there. So there are two methods to perform division. One is called restoring and another one is called non-restoring division. So these two are also very, very important. Many times he has algorithm on this and also problems on this. This is also one of the expected question. So I want you people to learn it thoroughly. That's why I am going very slow. In one class, I am just explaining you one topic. Okay.